In this example, we're going to focus on the task of debugging. Now that we're getting into writing short programs or script M files and function M files, opportunities start to abound for making mistakes that are difficult to figure out. So what I want to do here is introduce kind of a strategy for debugging your problems. And to do so, we're going to use the same example. This is the same as last week. And if you recall that problem, we had an I-beam and we wanted to calculate the cross-sectional area of the beam and calculate the mass of the beam and then round that mass to the nearest tenth of a kilogram. And so what we're going to do is take a little bit different approach, and I'll show these two script M files. The first script M file is called ibeam2.m. It's very similar to what we had last week, though the one change I've made is now for the end we're going to call a user-defined function that I've written to calculate the mass and round that to the nearest tenth, like we need to do for this problem. So instead of doing those calculations inside this script M file, since that's kind of a general problem to calculate a mass given volume and density and then maybe round that to a specific value, I'm going to write a function M file to do that. So the function M file is called roundmass.m. And again, this one is a function M file as indicated by the function command being the first command in this M file. Now, this roundmass function accepts three inputs: the volume, the density, and a rounding goal. And there's some instructions here as to how that rounding goal works. This is set up to just accept three options as the rounding goal, but there's no error checking. Note, I haven't done any error checking here. In other words, to see if when I'm using the function I input a value that doesn't make sense for round goal. And the reason that there's no error checking is because we don't know how to do it yet. We can talk later on in the quarter about how to incorporate error checking and defaults into your functions. But we need some programming tools that are a little bit more advanced to do that, and so we're not going to introduce those just yet. So here we calculate the mass in kilograms and then we round it using the strategy that we talked about last week. So what I've done is I've purposely put some mistakes into this solution, and these mistakes might be difficult to see just by reading the solution. And so what we're going to do now is move over to MATLAB and try this out and see if we can figure out what's wrong. Okay, so now I'm in MATLAB. I have it set up similarly to what we did in the last video so that we can see what's going on in the workspace and also step through these scripts in the editor window. I should note in this problem the way I've set it up is we have a script M file, which is our main solution that's specific to this problem, and then I've written a function M file which solves the more general problem of calculating the mass of the object and rounding that. And that function M file is general. It doesn't even require it to be an I-beam. It's only the script M file that's specific to this problem. And that's a good general guideline to use when you're trying to decide whether to write a script M file or a function M file. Is, do you think you might use that code to solve another problem later? And if you think that might be the case, then it's good to write a function M file that uses local variables, so you don't have to worry about variable conflicts, naming conflicts. So anyways, let's try running this and see what we get. ibeam2, and it runs. It seems to run fine. There's no errors, and there's no red syntax errors that come up, and we might think everything's fine, except we look at the results and we say, wait a minute, if this is our mass in kilograms, that doesn't seem right. That, if we could do this calculation by hand on our calculator, and we can see that that's not right. And then we can look again and say, wait a minute, this rounded mass, that's definitely 0.1274 is not 5.02 rounded. So something's fishy here, but it's hard to tell just by looking at this. And so the best thing to do is to go and use the debugger to step through line by line. So let's again review how to do that. So what I'll do is I'll go over to the editor window. I'm in iBeam2, the script M file. It's the first thing we run. And I'll set a breakpoint. And we have everything down here in our workspace from running it. But what I'm going to do actually before I run this is I'm going to clear, using the clear all command, I'm going to clear the workspace before we try and debug this, just so we can see how the variables are created as we step through. So I've cleared the workspace. I'm going to go back here, make sure that breakpoint is set. The clear all command also clears that breakpoint. And now I'm going to run it again and step through and see if we can discover where we might have a problem with our M files. So let's run iBeam2 again. So we'll run it. And here we are about ready to step through. So we assign a value to width, thickness, height, length, density. That's all pretty straightforward. Calculate the area. Okay, that seems right. We could check that on our calculator. Calculate the volume. We could check that on our calculator. And now the next thing we're going to do is calculate this mass, and that's the one we were a little suspicious of. So one thing here, since this is going to go into another function, we need to use a different debug command. Instead of just stepping, we need to use the step in, and that'll bring us into that user-defined function as opposed to just executing the command in the iBeam2 script. So to step into the function, we'll click step in, and now you'll notice down in the workspace window we have a stack. We have a workspace in round mass, and that now has dense, round goal, and vol. Oh, and there we maybe see a problem, and let's take a look at that in a minute. But first, we can see we have a workspace associated with iBeam2, and since iBeam2 is a script M file, you notice that workspace is the same as the base workspace. So these two workspaces, iBeam2 and base, are the same, since a script M file, like iBeam2, shares its workspace with the command window, or the base workspace. In contrast, a function M file, like round mass, creates its own workspace. So now we're in that workspace, and the first thing we notice is that these don't look right. Remember, in this function, the variable that's supposed to be a value of 0.1 should be round goal, but that's not the case. So let's see what happens. So it looks like vol got the value 0.1, dense got the value 50,250, and round goal got the value of 7.85. So this seems to be a pass by position problem. So what we can do is go back to iBeam2, and we see, aha, here's where we called it, and we put 0.1 for our round goal. We put that first in the output list, but that value should be last in the output list. And maybe that happened because here in our help comments here, we didn't even include round goal in the variable list for the help comment. So this is another reason why we want to make sure to keep our help comments comprehensive and accurate. So that's one thing we need to fix. Now let's go ahead and keep stepping through. So we'll step, and there we calculate the mass in kilograms. And that we know that that number's wrong because the volume and density don't have the right values because of how we called the function. we'll step again and we calculate the mass rounded, and we see that the mass rounded isn't even related to the mass kilogram, so we have another problem there. And again, no syntax error, but we've got a problem. And if we look back here, so we know there's a problem with that command now. And what we need to do is we need to change this division right here. We need to change that to a multiplication to make that rounding strategy work. So what I'll do now is finish the step out, and we'll come back to the script M file ibeam2 and finish that. And now let's go back in and try and fix those problems. So one thing we need to do is here in ibeam2, we will change the order of the inputs that we're sending to round mass. So let's do that. We'll save. We'll go to round mass. We'll change that division to a multiplication. We figured that out. Again, sometimes just having your calculator handy and following along with MATLAB, doing the calculations by hand. And then, so we don't make that problem with the inputs again, let's fix those help comments. Round goal. So 3 little mistakes here all led to our answers being totally wrong. So we did those 3 changes, and let's try running it again. ibeam2. And you know what, I'm going to clear this breakpoint and just run this all the way. And we come back here and we see, this looks a little more like it. There's our mass in kilograms, and then here's our mass in kilograms rounded, 394.5. But I'm a little bit confused because here's mass kilograms showing up in the command window, but mass kilograms does not show up in the command in the base workspace. So let's see why that is happening. And what we can do is go back and look, where is that variable mass kilogram used? It's not used in ibeam2, the script M file. It is used in round mass. So if we go back to round mass here, we'll see, there it is, mass kilogram, and there's that warning MATLAB's giving us, terminate statement with semicolon to suppress output in functions. And that's why we want to avoid that confusion where this variable mass kilogram shows up in the workspace, shows up in the command window, but doesn't show up in the workspace. So let's just put a semicolon there and fix that. And now let's go back to the command window and we'll run this one more time, and that's what we want. ibeam2, and we want it to display the area and the rounded mass. And that concludes this example. What I'd encourage you to do is just download these M files and play around with this. You can make other mistakes and see if you can find them. You also have more practice with this in the self-assessment for this week.